Okay, well, we'll begin. Happy Friday, and I hope you are all doing well. Let's take a look at what we got going on today. All right, so I just want to kind of look a little bit at like some application of like pivoting data, because I presented this concept of pivoting your data on Wednesday, and it's a little bit of like a weird thing, and you might wonder like why would I ever want to do something like that? Different reasons. One of them is in ggplot, when you map something to an aesthetic, you map a column, right? So you say, I want to map this column to the X position, and I want to map this other column to the Y position. And if you want to do that, then basically all the values that you want to plot need to be in a single column. And so anyway, here's an application of this. So we're going to look at this Gapminder data. So remember, this is just this data set on different countries, and it's got information about like what continent, and it spans from the years 1952 to 2007 in these 5-year intervals, and it plots values that for things like life expectancy, the population of the country, and also GDP per capita. Okay, and so we can kind of plot some of this stuff. And so again, here is the original plot, and here's just original data, and here's a simple plot that I created using this data, and my hope is we're starting to feel comfortable regarding how to read some of this code. So here I'm saying, take the Gapminder data, and we're going to just filter to these 3 countries. We're going to look at the United States, Canada, and Mexico, right? And then, and what I'm going to do here is I'm going to take the year variable and map it to the x-axis, right? I'm going to take the life expectancy column, map it to the y position, and then we're going to color our dots by country, right? And here I'm going to do geom points to get the points, the dots there, and then I also kind of want to connect them, so I'm going to add a geom line, and then theme line draw kind of just puts the grid lines on the plot. Okay, so this is, and so we see how life expectancy has risen dramatically for Mexico, and it's also risen for the United States and Canada, where in the 1950s life expectancy was less than 70 years, and it has kind of gradually gone up to for Canada, average life expectancy is over 80 years, and for the United States it's something around 77, 78 years here. Okay, so great. Okay, here is another plot. This time I am taking the y variable will be GDP per capita. Okay, and so GDP per capita is kind of in the thousands, and it goes anywhere from this looks around $4,000 ish, I don't know, to something over 40 something thousand in 2007 or something. Okay, and so this is kind of what we see. Hopefully we're able to read these things. Okay, here I'm adding a label. Okay, so there's a few ways. I think you can do GG title, which will change the title. Here I did labels, labs, title, and the title of the plot will be GDP per capita over time. And then regarding the vertical scale, I think the default is when it sees a bunch of zeros, like 10,000 and 20,000, it prints it in scientific notation. I think it would have been like 1e5 or something to kind of indicate 1 times 10 to the 5th power. Or no, I guess it's 4th power, 1e4, which will be 1 times 10 to the 4th power, or 3e4, 4e4, which is just kind of a little bit hard to read. So here I just said, this is an option to, print it out, 40,000, 40 comma thousand scales, comma, to get our our values printed like such. Okay, hopefully, so this is nothing new. Hopefully we're able to kind of read this and understand that, we've got a little, enough exposure through the homeworks and the data camp to understand how this works. Okay, all right, so let's do some pivoting of the data. So here, just to kind of remind us what the data looks like, here I said, this is what the data looks like if we just filter to these 3 countries. And so in our data, we have a total of 36 rows. I can really only fit like the first 18 rows on this slide here, but you can just imagine what the other 18 rows look like. So here it says, Canada, and we have 12 rows for Canada because we go from 1952 to 2007 in 5-year intervals. So that, covers a span of, 55 years, 12 different entries there. And then we've got the columns life expectancy, population, and GDP per capita. Okay. And then, 36 rows, 12 for each country, and then 6 columns here. And then what we're going to do is we're going to pivot. I'm going to pivot these 3 columns. Okay. So if I pivot the 3 columns, I'm going to pivot them longer. How many rows will I end up having? So the columns I want to pivot are life expectancy, population, GDP per capita. I'm going to pivot them longer. So what I'm going to do is I'm going to gather the values in those 3 columns, and I'm going to basically gather them into one long column. So how many rows do you think we'll have? Oh, 108, right? Because each column here, like the life expectancy column has 36 values, the population column has 36 values, the GDP per capita column has 36 values. And what we're going to do is we're going to take each of those 36 values and we're just going to put them all into one column. We're keeping there's 108 values, but we're putting them all into one column here. Okay? And then so all 108 columns, 108 values will go into one column. How many resulting columns will I have?
4.
I understand where you got 4. We're going to actually have a 5th column, okay? So these 3 columns get turned into one, okay? We're keeping the same country, continent, year. Those 3 columns remain. These 3 countries get turned into one, and then we get one more column to indicate which column it came from. So we're going to have a column called name, or whatever label I give it. But basically, it will, when these 3 values go into one column, we're going to have another column that says the 68.8 came from life expectancy, the whatever the number this is, 1478 came from the population column, and then 11,367 came from the GDP column. Okay, so that's what we get here. Okay, so here I take those 3 columns, I pivot them longer. Okay, and which columns did I pivot? I pivoted life expectancy through GDP per capita. All right, and then so the result, as we see, has 108 rows. Okay, and we have 5 columns. The 5 columns again. So those 3 columns with the numbers get pivoted into one column with value, and then we have a column called name that indicates where those values came from. So 68.8 came from the life expectancy column, 1478 whatever came from the population column, 11,367 came from the GDP per capita. Yeah.
What's the package that it
it's in the tidyr package, or you can just do tidyverse, and that will load up all of the packages necessary. Yeah.
What is the label name? Like, do you have to make it as the name, or is it just automatic?
So when you do pivot longer, it will automatically. So when you pivot a bunch of columns, it pivots them all the values into one column, and it creates another column for basically where those values came from. So here we took 3 columns and basically we pivoted the values into one, and we created another column called name. By default, it gives the column headings name and value, but you can customize it. So I think in one of the examples on Wednesday, we took the data and we put them into the name, the column headings corresponded to year, and then the values corresponded to the number of cases. So we called those things year and cases. But in our case, we're just going to just use the default value of name, basically name of the column that it came from, and then the value that we pivoted. So here I didn't specify name. I think it's names 2 and values 2. Those are the names of the columns you can specify. It will automatically create those columns. I didn't give it names, so it just uses the default of name and value. Yeah, question.
What's the package for using the colon instead of having C? For like life expense things.
Oh, that's no package. That's part of. Oh, I'm sorry. I guess that's part of dplyr. So if you do library tidyverse, it should load up everything.
I did that and it still like didn't work unless I used like C.
Huh. Interesting.
I'll try it.
Okay. Yeah. Okay. So here we did the pivot longer, and it should do this. Yeah, you can do library dplyr, and but it should be part of dplyr. Should get loaded when you do library tidyverse. Okay. So we pivoted the data, and one reason why we want to pivot the data is, again, when you create a plot in ggplot and you say I want to map an aesthetic to a thing like y position, you can really only specify one column, right? You could like have a different table and you could specify columns from that table, but that's what we want here. So if you read the code on this next plot, basically I have the same starting rows. We're starting with the Gapminder data. We're filtering the data to US, Canada, Mexico. I'm pivoting those 3 columns, life expectancy, GDP, and through GDP per capita. And then here I really just want to print life expectancy and GDP per capita. So I'm going to filter this name column just to these 2 values, life expectancy and GDP per capita. Okay. So there's 3 different values here, but I'm just going to filter the name column just so I only have those 2 values. So basically filtering from 108 rows down to 72 rows. Okay. We're going to have the life expectancy values and the GDP per capita values. Okay, and now I'm going to take that result, and then we're going to pipe it into ggplot. So one thing to kind of remember, a syntax issue, is as when you do dplyr things and you do things like filter and mutate and pivot longer and stuff like that, select, you use the pipe, which is % greater than %. Okay. But then once you use ggplot and you're adding elements in ggplot, you use the plus sign. Okay, so make sure you don't mix these things up because you're going to get error messages. So if you use plus signs between these things, you'll get error messages. If you use pipes in ggplot, you'll also get error messages. And those error messages, the error messages on R are generally pretty helpful, but when you as you get able to read error messages. That's an important skill to develop, by the way. You will encounter error messages, okay? And usually there's something contained in the error message that will help you figure out what went wrong, okay? If your attitude towards error messages is just, I don't know what to do, it's going to be very hard to kind of troubleshoot your code. But always kind of look at the error message, try to start putting in your brain, okay, when I encountered this error message, this was the problem, right? When I encountered this other error message, it turned out this other thing was the problem. And so start to try to keep track in your brain what problem was associated with each error message. And that way, when you encounter the same error message in the future, you can go in your brain and go, oh, what was the thing that caused that thing? And you can look it up, right? Another useful thing is just the internet, right? You go and you just copy part of your error message, put it into Google or Bing or whatever, and you see what other people did to resolve their error message. So being able to read error messages is a very important skill to develop. Also being able to just read help pages. So there's the internal documentation in R, and then when you go online and things, right? So again, I present stuff, and I'm proud of the stuff I present in class, but there's only a little bit I can really do, and a lot of it you have to kind of you have to do the exercise and the workouts on your own to do these things. Okay, so anyway, going back, we're taking this, we're filtering it down just to life expectancy and GDP per capita rows, and then we're going to create a plot. We're going to take the column year, put that on the x-axis. We're going to take the value and plot the value on the y-axis, and we're going to color our dots based on the country. And we're going to do lines and points, theme line draw, and then you guys used facet wrap, right? And so what's facet wrap tilde name going to do? So here I've got the name column, which right now we've filtered down to life expectancy and GDP per capita. So when I facet wrap tilde name, what is this going to do? Is going to make kind of two individual plots, right? One plot for name life expectancy and one plot for name GDP per capita, okay? And that's what we get, okay? So here is a plot showing the year versus the value for Canada, okay? I mean, for the three countries, Canada, Mexico, USA. What is this? Canada's red, Mexico's green, USA's blue, all right? And so that's GDP per capita on this one. And what happened over here? For life expectancy, what's going on here? So what happened is, okay, we're talking about GDP per capita, which is something like, $30,000, $40,000. What's human life expectancy? 70 years, something like that. Okay, so when you put them, by default, when you do a facet wrap, it puts them on the same scale, okay? And so this is going from 0 to, 40,000. And so all the life expectancy numbers are like, in comparison to 40,000, very close to 0, all right? So we, this, unfortunately, by using this scale, it's kind of useless. We can't really plot anything, right? We can't make sense of it. So to kind of address this thing, we can, when you do a facet wrap, you can use this option called scales equal free. And that's going to allow the left-hand plot and the right-hand plot, or the different plots that it's creating, to have different scales, okay? So it kind of assumes you're kind of using the same variable and you're like faceting based on like, I don't know, different groups. Like you're going to have a plot for male over here and a plot for female over here. Or you're going to plot, this thing. And then, for life expectancy, there's a difference between life expectancy for men and women, but they're kind of on similar scales. And so, in that case, it makes sense to have, have a common scale for both plots for comparison. But here we have very different scales for these two variables. And so in this case, it makes sense to scale them freely. Also, what I want to do is I want to change the titles for the different facets. Here it's just using the names, which is GDP per cap and life exp, right? Which we can understand, but I want to provide slightly more informative labels that are a little bit more reader friendly. And so so in the next thing I add some more code. Okay, so for facet wrap, I'm going to so the original code was facet wrap tilde name. For this one, I'm going to do facet wrap tilde name, and then I'm going to put in the option scales equal free, and that allows the two plots to have different scales. And then here I'm going to add labels using the labeler. Okay, and so to create the labels, you have to create this as labeler thing. Okay, and you save it somewhere called labels, and that's where I'm putting in here. I create this labeler object, and inside the labeler object, I say, okay, the thing that's currently labeled GDP per capita, I want you to replace it with, GDP space per space capita, right? So we want to do that. And then this thing that's currently labeled, LIFE EXP, I want it to be replaced with the label life expectancy in years. Okay, and this is just to kind of make the plot more friendly for the, a reader who's not familiar with the data set itself. Okay, and so this is what we have. So now life expectancy has its own scale, kind of going from 50 to 80 something, and then GDP per capita is on this scale, right? And so this is our plot, and all to show what is being communicated here, that both GDP per capita and life expectancy have increased over the years. And life expectancy in Mexico has made dramatic improvements over the last 70 years or so, where in the last in 2007, the difference between Mexico, U.S., and Canada, Mexico's looks to be around 76, 77. U.S. is around 77, 78. All within just a few years of each other. Okay. Whereas, there was a very large difference in the 1950s, okay? GDP per capita has also kind of climbed for all countries there as well. Okay, so that's just kind of like a little example of using some of the pivots, for plots. And then I'm going to just do a couple exercises from the textbook, from the chapter on pivoting data as well. Let me go ahead and give you your first view quiz answer for today, which is the letter C. C as in cat. C as in cat is our first view quiz answer for today. Okay. All right. So this is from the textbook. Okay. And so if we go to the textbook. Is this the here it is. Okay, so this is the online version of the second edition, and we're gonna look at the exercises and the tidy data. And which one did I say? Problem 5. Okay, so here it says generate the code to convert the following data frame, which is here, into wide format, okay, which looks like this, which is a little bit strange. All right, and so what we're seeing here is we have group A and group B, we have sex F and sex M, and we have I don't know what these things are: mean L, standard deviation L, mean R, standard deviation R. So something about the left, maybe right, I don't know, left and right, but I don't even know what they're measuring, okay? Unfortunately, this information, I don't know what these things are. But what we want to do is we want to turn these things into this, right? So we have 4 rows, and we want to just have 2 rows, 1 row for A and 1 row for B. And if we look at it, what we have is we basically take these values, 0.225, 0.106, 0.34, 0.0849, and we're putting them here. It looks like we got the means and then the SDs for the female, and then means and SDs for the male here. And then so basically the column headings, we have f.mean L, f.mean R, f.SDL, f.SDR, and then we have m.mean L, m.mean R, m.SDL, and m.SDR, right? So we can see what's happening, right? Basically, we're taking this row here, okay? And then we are basically like copying it and sliding it up there, and then we're also taking this row and we are basically moving it up over here. So we can see that. How do we write the code to do something like that? Our tools are pivot longer and pivot wider, okay? Pivot longer takes multiple columns and puts it into one. Pivot wider takes one column and spreads it across multiple things, okay? So we have a little bit of a thing, right? We don't have anything that says, okay, go from 4 columns to 8 columns, or do something like that. So we really only have two tools. So we can either so we're gonna basically have to pivot. What we're gonna do is we're gonna pivot these 4 columns into one column, and then we're going to pivot that one column into 8 columns. And so how are we going to do something like that? So first I'm going to just get the data into R. And so I kind of just manually recreated the table here. So here's our data, and we're going to pivot. Okay, first I'm going to just pivot these 4 columns. Oops. Okay, so this is 4 rows and 6 columns. Okay, and I'm going to take these columns, mean L through SDR, and I'm going to pivot them into 1. Okay, so how many rows are we going to end up having? Well, we look at how many unique values, okay? And I've got 16 unique values. So we're going to end up with 16 rows, okay? And then we're going to have 4 goes down to 1, and then we're going to have a name column. So we're going to have 4 columns in the resulting thing, okay? So 16 rows, 4 columns. So this is what we have. Okay, and now we can kind of see, all right, I can, if I pivot wider, and I say pivot this wider based on group, okay, then we can see, all right, I've got 8 unique values for group A and 8 unique values for group B, okay? So that's a good sign. But right now, my columns, I don't, but I can't do that. You don't pivot wider based on what the rows are. You pivot wider based on the columns. So what I need to do is I need to create 8 unique values, okay, for basically the names of the columns. And so right now I have a column for sex and a column for name. So what I need to do is I need to create basically a column with these values, f.meanL, f.meanR, f.SDL, and so on and so forth. Okay, and so that's actually not very hard to do. What we do is we're going to use a text operation that's going to basically take the names of the columns and just kind of glue them together. Okay, so there's a text operator, okay, called paste, and basically it just takes the text in one column and it glues it or pastes it to the text in another column. There's paste 0. The regular paste by default puts a space between the column things. Paste 0 will not put a space between the column things. So here what I want to do is I want to take the text in the sex column, which is just the letters F or M, and we're going to paste it to a dot, and we're going to paste it to the text in the name column. And so so that's going to create, f.meanL, f.SDL, f.meanR, f.SDR, okay? And basically, because I'm creating a new column, I'm going to use the mutate verb, right? So after I'm pivoting longer, I'm going to mutate, and I'm going to say this new column I'm creating is called var underscore name, and I get this. Does that kind of make sense? What's going on here? All right, and so now I have 8 unique values here, and then we can pivot wider. All right, so I can take the values, the variable names, and I can pivot this wider. Okay, so I go pivot wider, names from variable name, values from value. Okay, and it does the operation I want, but then I also get all of these NAs, and I still have 16 rows. Okay, which is not what I want. Okay. And the problem is that I still have this column for sex and the column for name. And so because these things, sex and name, kind of each form unique things, when I pivot this wider, it can't combine those things. So what we need to do is before I pivot wider, I need to get rid of these 2 columns. Okay? So first, so I pivot longer, I mutate to create the variable name, and then I'm going to select only those variables, the group, the variable name, and the value. So I get rid of the original column sex and name. So after pivoting, so I pivot longer, and then I create the new column, with f.mean L and m.mean L and so on and so forth. This is what I have. And now I can pivot this wider. I don't have, the other variables to kind of cause me trouble. And we get the values that we wanted here. Okay, so here I'm saying take the values in the value column and pivot those wider. So currently they're in one column. We want them spread across multiple columns. What are you going to call your multiple columns? We're going to use the variable name. So we use pivot wider, values from the value column, names from the variable name column, and this is the resulting table that we get. Okay, which is what we wanted. Okay. Oh, you know what? I have a slight difference in this table. The columns are in a different order: f.mean L, f.mean R, f.stl, f.sdr, and here they end up in a slightly different order. So I can just do select again, and if I do select again, I can put the columns in the order that I want. I forgot to do that, but this is the operation. Okay. Do we feel okay about the steps that we took here? So it is a little bit of work and labor, and a lot of this is kind of just like thinking and problem solving, right? You got a certain number of tools, your tools, the functions that you have: pivot longer, pivot wider, mutate, summarize, group by, filter, select. They're each capable of doing one thing, and it's kind of just like, okay, can I piece them together in such a way that it's going to end up doing what I want it to do? And I would say in like 90-something% of your cases, like, yeah, these are sufficient. Okay, so each one is a pretty simple thing, but you can kind of piece them all together, right? It's kind of just like, I don't know, like in engineering, there's only a certain number of like simple machines, right? Like you've got the wheel and you've got the gear, right? A wheel with little teeth on it and inclined plane and a wedge and stuff like that. But yeah, and a lever, and you put all of these things together and you can create really complicated machines. But at the heart, they're just simple little operations kind of linked together. All right, let me go ahead and give you your next view quiz answer, which is the letter D. D as in dog. D as in dog. Okay, here is another exercise from the textbook. Okay, and it says an analyst wants to calculate the pairwise difference between the treatments for a small data set from a crossover trial. So all subjects received both treatments and the following observations. Okay, so we have ID1, ID2, ID3, treatment and control, and their values are 4, 4, 6, 8, 5, 6, 10. And again, this is just from the textbook. All right, and it says, verify that this code works for this example and generates the correct values of -1, 0, and 2, and describe two problems that might arise if the data set is not sorted in particular order. Okay, so what we can do, all right, is we can just, I can take our data, okay, and I can filter to just the treatment, okay, and I can also filter to just the control, right? So I can take our data and I can say, let's look at filter the treatment rows and filter to the control rows, and then I can take the treatment data, which has ID 1, 2, 3 treatment and values 4, 6, 8, and then I can mutate, all right, by just taking the value in the control data set, adding that, and then I can calculate a difference column by taking the difference between the values and the control, right? I can say take the values and the treatment and then the control values and then take the difference, and we get that. Okay. So that's one simple way to do it, right? I just kind of filter them and then and then I just kind of use mutate and to calculate the difference. Okay. One thing that could happen though is you might have your data, and they might exist in a couple different tables, but they might not be sorted in the same order every single time. And so here I kind of just swapped these two rows. So I have treatment ID number 2, ID number 1, ID number 3, right? So this could happen, and it's I don't think it would be a shock to anybody to find out that at different times the data got put in slightly different order. And so if I use this same kind of operation here, right, where I say, all right, let's filter to treatment, filter to control, and I'm going to calculate a difference by doing the treatment values minus the control values. Unfortunately, this doesn't have a when you just do mutate, it's just going to assume all the values are already in the order that you want, and it doesn't do this kind of checking to make sure they're in the order. If you do want to do this, you either have to do a join, and you say join on ID to kind of make sure ID 1 matches with ID 1, ID 2 matches with ID 2. So you either have to do a join operation first. So that's one option to kind of handle that, is you do a join operation. Okay, because here my values end up wrong. I get -2, 1, and -2 rather than the correct values of -1, 0, and -2. Okay, so so I have to do a join operation first. Okay. Or a better approach is if you have your data something like this, then you do a pivot wider, and when you do a pivot wider, then dplyr or R is going to make sure that all of the IDs get matched up correctly. So here I'm going to take the values in the vals column, pivot those wider across 2 columns, okay, based on the grouping variable, and it's going to make sure. So notice ID 1 has a 4 and a 5, okay, and it matches those up, okay, and ID 2 has a 6 and a 6, okay, and so it matches those up. So when it pivots these values, which are currently in order 5, 6, 10, when it pivots them wider, it rearranges them so that the IDs match up. Okay, so we're taking the values from the vals column, names from the groups column, and it tries to match them up based on the other variables that were not pivoted, right? So it's using the ID values and it's pivoting based on that. This is the reason why when I didn't filter out back here, when I took this thing and I didn't filter out or select the columns that I wanted, it created this whole mess of NAs, is because it takes the columns that are not being pivoted and it basically collapses the ones that are duplicates of each other. Okay, and here we have no rows that are duplicates for the columns that were not pivoted. Right? There's if we look at the columns that were not pivoted, which are group, sex, and name, there's no duplicates. We have A, F, and mean L, A, F, and SDL, A, F, and mean R. There's no duplicates there. Okay, so it can't collapse those. Okay, so but if I select only these columns after I pivot these 2 columns, then we have a whole bunch of A's that can get collapsed into one row, a whole bunch of B's that can get collapsed into one row. Right. So when you do something like when you pivot this, it takes the columns that were not pivoted and it collapses them based on kind of duplicate entries. So if you did have other kind of columns in here, other than ID, you had something, I don't know, date, okay, and the treatment was done on like March 1st, and the control was done on March 3rd, and you try to and you pivot those, okay, it's going to see March 1st and March 3rd as different values, and it's not going to collapse those. So you're going to get some kind of thing there. So you either have to say, okay, I need to get rid of those columns or something like that. Okay. Versus like if you had the name column, we would expect ID2's name, Joe, to be the same as ID2 Joe over here, and you would have duplicate rows, and it would collapse ID2 and Joe into the same row. So those are things that you got to kind of keep in mind and think about when you pivot your data. Okay, so here I've pivoted it wider, and then now that I've pivoted wider and we know the values line up according to the ID, then I can just mutate and just take the treatment column minus the control column and create our difference column here. Okay, and these are the correct values. It's I guess in a little funny order, 2, 1, 3, and so I can arrange it based on ID, and I can get it in the ID order 1, 2, 3, so on and so forth. Okay. All right, well, that's actually all I had planned for today. Let me give you your last view quiz answer, which is the letter A as in apple. And yeah, I guess my hope is this hopefully puts the pivot longer and pivot wider into a little bit of a better context as far as like why you might want to use some of these features or functions. They are a little bit, I think, stranger than, say, your filter or your select or even your mutate variables, okay? Or mutate functions, okay? Summarize is a little bit strange because, again, it changes the dimensions of your tables. I think anything that changes the dimensions of your tables, I think students struggle a little bit, right? So summarize will basically collapse all the, your grouping variable. It's going to collapse them all into this, into one row, and then you get summary values. And then pivot longer, pivot wider certainly changes the dimensions of your tables. But they are, in my opinion, they can be very useful, very powerful tools. Okay, again, third view quiz answer is the letter A as in apple. And that will be it for today. Have a great weekend. I don't have office hours today or tomorrow. I'm going to be out of town. So so that will be it. But we will see you all next week.